Okay, Calculus 3 students, this is yet another video, a tutorial video. There, there could be some blinking in this video because I'm using a MacBook, and it's a nice little laptop, but it does not have the greatest graphics card on the market, so the quality of the video could be a little, not so great, but that's okay. All right. So I don't think uh, I don't think my video has to be nominated for some Academy Award. It should be good enough. Okay, it should be good enough. Okay, what I would like to do in this video is go through problems 90 to 110 in the first part of your chapter 12 homework. Now, please be advised, as you can see here, today's date is Thursday, October 15th. This is probably going to be my last video for about a week because, number one, I need to make some tutorial videos for my other two classes. Okay, I cannot ignore those students. Number two, I have to complete some Title IX training for Oakton College. So that means for the next few days, I have to watch these videos on Title IX, uh, uh, racial discrimination in the workplace, sexual harassment in the workplace, a lot of that stuff. Uh, Basically how to get along with other people in the workplace. And, it is a requirement, and I'm going to have to spend some time working on that. I also have to go through the midterm class lists. So, actually, for the next week or so, I'm going to be kind of busy. Okay, so for the next week or so, you guys are going to have to work more or less independently. So let's try to get done. Let's try to do as much as we can do in this video. Let's try to get done as much as possible in this video because this will be, excuse me, this will be, my last video for the Calculus 3 class for about a week. So that's just a heads up to let you know. Okay, problem number 90. Use the two-path test to prove that the following limit does not exist. So we have this function here. It's a function of x and y to the fourth minus 2x squared divided by y to the fourth plus x squared. And I'm going to define that right now in Mathematica. Okay, f of x and y is equal to y to the fourth power, that's control 6, y to the fourth power minus 2x control 6 to the power of 2, control divide by y control 6 to the fourth power plus x. I mean, I could just do this, caret 2, but if you want it to look prettier, you can do control 6 to the power of 2. Okay, and shift enter. Now let's see. What value, I'm reading right here, right over here where the cursor is, what value does f of x and y, that expression, approach as xy approaches 0, 0 along the x-axis? Okay, so let's test that out. Let's see. It looks like the answer is -2. I mean, we can test this using the table command. Table. Oh, let's see now. F of k 0. K goes from negative 0.001 up to 0.001 in steps of 0.00025. Oh, yeah, so we of course, we can't have 0 in there, and that's perfectly okay. And that's fine. So let me store this in a list. My list. Okay. So of course, if you have x is equal to 0 and y is equal to 0, the function is not defined because then you're dividing by 0. Okay, that's not going to work. But for values that are close to 0, you can see that the limit is going to be negative 2. Let's see if that's true. Oh, sorry about that. Okay, as f of x and y, okay, f of x and y approaches negative 2. Okay. So now we're being asked, what value does f of x and y approach as xy approaches 0, 0 along the y-axis? Okay, so we can do the same thing. Let me just copy and paste. Let's see. I'll call this my list 2. Table form. That's good enough. And again, we're getting a warning message because you're not allowed to divide by 0. Oh, I'm sorry. Here, this is this time. Y. We're moving along the y-axis, so I'm going to clear my list 2. Okay, so now if we're moving along the y-axis, we can see that we're approaching 1. We're approaching 1. F of x and y approaches 1. Okay? And that is correct. Why does the given limit not exist? As x, y approaches 0, 0 along different paths, f of x and y does not always approach a finite value. That's not exactly the reason. I think it's going to be B. As x, y approaches 0, 0 along different paths, f of x and y approaches 2 different values. And that is correct. Let's move on to the next question. Okay. Now, let me tell you something about limits. Proving that the limit doesn't exist, that's really not too difficult. Proving that the limit does exist and proving what the limit is, that can actually take a lot more work. For something like that, I strongly recommend that students use the limit function in Mathematica. I know some math teachers will tell you it's the lazy way of doing things. I don't agree with that because actually we have a lot to cover in this class. And we can't spend an entire month talking about limits, okay? So we have a lot of other things we have to do. So to help you with the homework, in this video, later on in the video, I'm going to show you how to use Mathematica's limit function, okay? But that's going to be a little bit later on in the video. By considering different paths of approach, show that the function has no limit as xy goes to 0, 0. Okay. We're looking at the function f of x and y is equal to negative x divided by the square root of x squared plus y squared. Okay. One moment. Okay, let me clear f. F of x and y is equal to negative x, control divide by, control 2, x squared, oops, sorry about that, plus y squared. Shift, enter. Okay. And then it says here, find the limit as x, y approaches 0, 0 along the path y is equal to x for x is greater than 0. Okay. Okay, I had to pause the video for a few seconds. My dog was upset because there are people outside doing some work. So, okay, so y is equal to x. Y is equal to x. So what happens if we have f of x and x? Remember, y is equal to x. Okay. Well, my dog is going at it again, guys. We're just gonna have to try to ignore him. Okay, so here we can do a simplification. We can do a simplification, but the problem is we know that the square root of x squared is equal to x. However, you know, that's only true if x is a real number. Okay, my dog is really going at it. This is why it is not easy to make these videos at home. But we're going to try our best. Okay, so all Mathematica knows is that x is a symbol. All Mathematica knows is that x is a symbol. Mathematica doesn't understand that x represents, you know, a real number that could be negative or 0 or positive. So one way of doing that is this. Okay, full simplify. I mean, I could simplify this myself without Mathematica because I realize the square root of x squared is equal to x. However, there is also the issue of whether x is positive or negative. So let's see what we can do. Assumptions, element, x belongs to the reals. Okay, so sine x, let me explain what this means. Okay, and let me store this in an expression. What should I call it? Douglas expression. Why Douglas? Because that's my first name, so why not? Okay, Douglas expression. What is the sine of x? I don't mean sine, S-I-N-E. I mean sine, S-I-G-N. Okay, so what is the sine of 10? It's 1. What is the sine? What is the sine of 0? It's 0. And what is the sine of negative pi? It's negative 1. So the sine function, SIGN, is going to return either 0 or positive 1 or negative 1, depending on whether the number is equal to 0, greater than 0, or less than 0. So what I have here is an expression, sine x, well, negative sine x divided by the square root of 2. So here, if I have, okay, find the limit as xy goes to 0, 0 along the path, y is equal to x for x greater than 0. Well, the sine of any number greater than 0 is going to be 1, but don't forget I have that negative out here. So it's going to be negative 1 divided, you know what, I don't think, I'm going to have to rationalize my fraction because otherwise I don't think Pearson will accept it. So it should be negative square root of 2 divided by 2, which is really the same thing as negative 1 divided by the square root of 2. But I think Pearson wants you to rationalize your fractions. Pearson doesn't like radicals to be in the denominators of fractions. The people who programmed Mathematica don't care about that, but the people who programmed Pearson do care about that. Okay, but I'm pretty sure that's going to be the correct answer. Okay. And then it says, find the limit as x, y approaches 0, 0 along the path. Y is equal to x for x is less than 0. That's going to be the same thing, except the sign is going to be reversed. So we're going to have the square root of 2 divided by 2. And that's correct. So why doesn't the limit exist? Well, I can tell you that the limit doesn't exist because these two numbers do not equal each other. They do not equal each other. So therefore, the limit doesn't exist. And you can see it from the picture. You can see it from the picture. There's a discontinuity right over here. Excuse me. There's a discontinuity right over here at the origin. Okay? So why doesn't the limit exist? Let me see. The limit does not exist because f of x and y has different limits along two different paths in the domain of f, as f of x and y approaches 0, 0. And once again, I'm going to have to emphasize this because some of you may not get the point. Proving that the limit doesn't exist usually is not that bad. It's usually not that difficult. Proving that the limit does exist and then discovering what that limit is, that's a lot more work to do. That's much more work, and that can get a little bit intense. So for something like that, I really insist, at least for this class, I insist that you guys use the limit function in Mathematica because it's going to make your lives easier. Remember, we can't spend a whole month working on limits, okay? We don't have that luxury. We can spend a couple of days on it, and that's fine, but then we have to move on to other things because this course covers a lot of material. And by the way, if you take a course like this at Northwestern University, and I know because I've looked into it, at Northwestern University, multivariable calculus is actually taught in 2 sequential courses. Not just one course, but 2 courses. So this course is very dense. It encompasses a lot of material. And in my humble opinion, this course really should be split into 2 courses to be taken over a period of 2 semesters, because it really is too much to cover in 1 semester. It really is too much to cover, okay? But that's just my opinion. Okay, so that's correct. Let's move on to the next question. At what points of R2 is the following function continuous? This is a polynomial function. Okay, I'm not taking the square root of any negative numbers. I'm not dividing by 0. So this should be continuous for all points in R2. All points in R2. And that should be correct. Okay. Next question. Describe the largest set S on which it is correct to say that f is continuous. So here, I see. Okay. So here you have to ask yourself the question, are we ever dividing by 0? Don't worry about the numerator. Think about the denominator. Is the denominator ever equal to 0? It's impossible. Okay, it's impossible because x squared is always positive, or 0. It could be 0. Y squared is 0 or positive. But for any values of x and y, the numerator has to be 7 or some number greater than 7. So therefore, the answer should be the entire xy plane. Okay, so some of these problems, guys, I realize it's a lot of homework, but some of these problems are really not a big deal. You should be able to do them, in a minute. So it is a lot of homework, but some of the problems are challenging, but there are many problems in the homework that are really not that bad. Okay, they're not that bad. Okay, so at what points of R2 is the following function continuous? Okay, my dog is really going to town. All right, we're just going to ignore him. So again, we have to think about this. If you expand the denominator, here, hold on one second. Okay, if you expand the denominator, you're going to have x to the 4th power y squared plus 16 x to the 4th power. Okay, so let's see. There we go. Okay, now think about this denominator. When is this going to be equal to 0? If x is equal to 0, then this expression becomes 0, and this expression becomes 0, which means I'm dividing by 0, right? So I'm going to choose A, all points x and y such that x is not equal to 0. Okay, I hope that made sense. Let me just erase this. Okay, let's do 95. At what points of R2 is the following function continuous? Okay, so this is where I'm going to show you how to use the limit command. Here we go. Clear F. f of x and y is equal to x times y, control divide by 6x to the power of 2 plus 5y to the power of 2. Okay. Oh, actually, well, no, that's fine. Yeah, this is fine. Now, what happens when x and y are both 0? Okay, it's indeterminate because we're dividing by 0. So now the question is, what is the limit as x and y approach 0? So what I'm going to do is very simple. We're going to type limit f of x and y as x, y approach 0, 0. Okay, it's indeterminate. It's indeterminate. It's not 0. It's not 0, which means, so let me explain something to you. This is a piecewise function. When x and y are equal to 0, 0, f of x and y or z will be equal to 0, but it's not equal to the limit. It's not equal to the limit. Therefore, and this is an important concept, okay, let me see which, okay, all points except the points 0, 0. Now I realize in Mathematica you would type this. You would type that, okay? That's not acceptable Pearson notation. That is acceptable Mathematica notation. It is not acceptable Pearson notation. And let's see. Okay, so far doing pretty good. At what points of R2 is the following function continuous? Well, now think about it. Think about it carefully. The quantity under the radical sign, is it ever negative? It's never going to be negative. It has to be 0 or greater. So therefore, the answer is simply all points in R2. And we're done. At what points of R2 is the following function continuous? So here we have a log function. And by the way, just so that you understand, okay, the log function in Mathematica is capital L-O-G, not L-N. The log function in Mathematica is capital L-O-G. It is not L-N. I hope you're clear on that. Okay, so think about this. Can you take the natural log of 0 or a number less than 0? So the answer is no. So what is the log of 0? Okay, negative infinity. What is the log of negative 3.9994? Okay, it's a complex number, but we're not working in the complex domain in this course. Okay, so we're only interested in real numbers. This number has an imaginary part, so we're not interested in dealing with that in this course, right? So this quantity, okay, this quantity x minus 4y must be greater than 0. X minus 4y must be greater than 0. Let's see. All points of R2 satisfying the inequality x minus 4y is greater than 0. And let's see if that is correct. Let's see, hold on a second, check answer. Okay, that is correct. At what points of R2 is the following function continuous? Let me just erase what I wrote. At what points of R2 is the following function continuous? The function is continuous at any point in R2. Any point in R2. Okay. Describe the largest set S on which it is correct to say that F is continuous. Okay. Well, x squared plus y squared minus 121 must be greater than 0, which means x squared plus y squared must be greater than, yeah, x squared plus y squared minus 121 must be greater than 0, which means that x squared plus y squared must be greater than 121, which means the choice should be B. Sorry about that. It should be option B. Okay, at what points of R2 is the following function continuous? So, hold on one moment. So we're going to have 49 minus y squared minus x squared has to be greater than 0, which means that negative y squared minus x squared has to be greater than negative 49. So what happens if I multiply this whole inequality by negative 1? Negative 1. So I'm going to end up with x squared plus y squared. Let me make this look a little nicer. Is less than 49. That's actually going to be a circle in R2 of radius 7, but you're eliminating the outer edge. So let's see. Oh, actually, yeah, this should be, because you can take the square root of 0, this actually should be greater than or equal to, less than or equal to, and this should be greater than or equal to. Okay, sorry about that. And the answer should be D. The answer should be D. Yeah, so this is a circle of radius 7, and you are including the boundary or the border, the edge of the circle, the circumference of the circle. So that should be correct. Okay, so hold on one second. Let me just erase that. Okay. Describe the largest set S on which it is correct to say that F is continuous. So again, we're going to have x minus y plus 9 is greater than or equal to 0. Okay, So we can change that to x minus y greater than or equal to negative 9. Okay, so what happens if I multiply this by a negative 1? So I'm going to have y minus x less than or equal to 9. Okay, and that should be the answer. So let me see. Well, and then of course you can do this. I think what they're looking for is 9 plus x. So actually, wait, that's getting a little messy. Okay, y is less than or equal to x plus 9. Y is less than or equal to x plus 9. And let me see here. It's going to be option A or choice A. Okay. At what points of R2 is the following function continuous? So again, we need to find the limit. Actually, the limit here is very easy. This is a calculus 1 limit. So you guys should remember this from calculus 1, okay? This is a very famous limit. What is the limit? Sine theta. If I want theta in Mathematica, I press escape. Theta, okay, divided by theta. And theta goes to 0. This is 1. The limit is 1, okay? So here, one second, let me just move this window. Here, I can see that theta is equal to 8x squared plus 5y squared. So the sine of theta divided by theta, that limit is going to be 1 as x and y goes to 0, 0. So let me see here. All points in R2, and the reason is because there is no discontinuity in this function. The limit is the same as the function value. The limit is the same as the function value. So there is no discontinuity in this function. So I hope you guys understand that concept. All right, so if this value, excuse me, if this value was anything besides 1, if this value was anything besides 1, then the function would have a discontinuity at x is equal to 0 and y is equal to 0. But because the function value is 1 when x is equal to 0 and y is equal to 0, the discontinuity is essentially filled in. Therefore, this is continuous for all points in two-dimensional space. Okay? So here we have to evaluate the following limits, and that should be pretty easy to do. Okay, so clear f. Okay, one second. Clear f. And f of x, y, z is equal to z times e to the power x and y. Remember that in Mathematica, excuse me, in Mathematica, a space means multiplication. If I type a space A space between two expressions means that I am multiplying those two expressions. So this is z times e to the power x times y. All right? So x is 1, y is the natural log of 3. Okay, so x is 1, y is the natural log of 3, and z is 4. And the answer is simply 12. It's very simple. Very, very simple. And that is correct. Okay, determine, now let me see. This is more of a theoretical question. I don't think we need Mathematica for this. We could use Mathematica to help visualize the problem, but that would actually make the problem more complicated. Determine whether the following statements are true and give an explanation or a counter example. Part A, if the limit is x0 goes to 0, 0, f of x and 0, and the limit 0y goes to 0, 0, f of 0y exist and equal L, then we know that this limit exists. Choose the correct interpretation below. Well, I can tell you the answer is wrong. It's false, okay? So it's either going to be A or B. The statement is false because f of x and y must approach the limit as xy approaches AB along all possible paths. The function f of x and y, x times y divided by x plus y is a counter example. So it's not going to be B because xy divided by 2 is going to be continuous everywhere. Here, f of x and y, where I'm dividing by 0 in the denominator, that is a counter example. That is a counter example. So here we're going to choose option A. Okay, it's not so bad. We're not done with the problem. Okay, continue. If the limit, excuse me, so part B, if the limit as x and y approach a and b, where a and b are actually real numbers, f of x and y is equal to a certain number L, then f is continuous at a and b. Choose the correct interpretation below. That's not necessarily true. It depends on the function definition. It actually depends on the function definition. So the statement is going to be false. Let me, okay, hold on one second. The statement is false, but I'm trying to figure out which false. Is it B or C? So the statement is false because the limit of x and y as xy approach AB of f of x and y must equal f of a and b if f is continuous. Hold on one second. The function f of x and y, 2 if x is 0 and y is 0, 1 if x is not equal to 0 and or y is not equal to 0, is a counter example. The statement is false because the limit as xy goes to AB, f of x and y must equal f of a and b if f is continuous. This one is a little bit tricky. It's either B or C. Hold on one moment. Let me turn on my powers of concentration because the way they're wording the problem is a little weird. So it is continuous. The statement is false because the limit of x and y as xy goes to AB of f of x and y must equal the definition of f of a and b if f is continuous. I believe it's going to be B. Yeah, that one's a little bit tricky. That one's a little bit tricky to think about, but basically what they're trying to say is that if you have a continuous function, okay, then sure, there could be a point of discontinuity, but then the way you define that function at that point of discontinuity must be equal to the limit of that function at that point of discontinuity. This is a very subtle concept. It's not easy to explain. And guys, this is where you really must read your textbook. You must read your textbook because, okay, I'm losing my voice here. This is another reason why I don't like to make long videos. Yeah. But this is a subtle concept, and this is where I insist you must look at your textbook. Because explaining this to students can be really hard. It's a very subtle concept, but let's continue. Let's move on. Okay, determine. Oh, I see. This problem has part C. This is okay. This is a multi-parter. Definitely a multi-parter. If f is continuous at the point AB, then the limit as xy goes to AB of f of x and y exists. Choose the correct interpretation below. So let me read that one more time. If f is continuous at the point AB, then the limit as x and y goes to a and b of f of x and y exists. Choose the correct interpretation below. The answer is true. The answer must be true because the limit as x and y goes to ab of f and xy is equal to f of a and b. Okay. And there's a part D. Okay. If P is a boundary point of the domain of F, then P is in the domain of F, and that is not necessarily true. If P is a boundary point of the domain of F, then P is in the domain of F. Choose the correct interpretation below. I can give you one really good example. The natural log function. Let me move over to Mathematica for one moment. The log of x, where x goes from 0 to 10. Oh, sorry about that. Here, plot the log of x as x goes from 0 to 10. Okay, so I can see from the graph that 0 is a boundary point of the natural log function. However, it is not included in the domain of the natural log function. Okay, so this is definitely going to be false. Let me see. I believe it's C. The statement is false because if the domain is an open set, then it does not contain any of its boundary points. The function f of x and y is equal to the natural log of x plus y is a counterexample. Next question. Okay, and then I believe we have to evaluate a bunch of limits. Now, guys, there are some algebraic methods for doing this, but they're complicated. It's messy. This is where I insist. Use the limit function in Mathematica to make my life simpler, to make your own lives simpler. So that's what we're going to do. That's what we're going to do. So here we are asked to evaluate limits. So the limit as y cubed is equal, y cubed divided by x to the power 6 plus y to the power 3 as x and y go to 0, 0. It's indeterminate, which means the limit does not exist. The limit does not exist. Okay, next question. Use the method of your choice to evaluate the following limits. Okay. Now this is a weird limit. I believe... Okay, so one of the limit laws is that when you're taking the limit of a quotient, it's going to be the limit of the numerator divided by the limit of the denominator. So the limit of the numerator in this case is definitely a little weird. So if we have limit y times the natural log of y, as y goes to 0, I believe the answer is going to be 1. Oh no, sorry, it's going to be 0. Wait a minute. Yeah, it's going to be 0. Okay, why did I say 1? Okay, it's going to be 0. So then if you have, well, the limit in the denominator is obviously going to be 11. So you're going to have 0 divided by 11, which is equal to 0. So the answer is simply going to be 0. Okay? And that's actually a limit law, that when you take the limit of a quotient, it's the limit of the numerator divided by the limit of the denominator. Or you could simply do this in Mathematica. You could do limit y times log y divided by x as xy goes to 11, 0. Okay, and we know that, well, the answer is 0. And that should be correct. Okay, we're almost done. We are almost done. So here we have the limit, absolute value of x minus y divided by the absolute value of x plus y. Xy goes to 0, 0. Indeterminate, which means the limit does not exist. Okay, 1 second. The limit does not exist. Okay. This one should be pretty easy because I'm not actually dividing by 0. This should be pretty easy. I'm not dividing by 0. So x times y times e to the power negative x divided by x squared plus y squared, where x is 0 and y is 1. And the answer is simply going to be 0. And this limit is easy to figure out because I'm not dividing by 0. Now, if I was dividing by 0, the limit would be a lot more complicated to figure out, unless I'm using Mathematica. Okay, so therefore, I know that the answer must be 0. The limit is going to be 0. Okay, we are almost finished. 1 second. Okay, so we have the limit 1 minus cosine y divided by 2 times x times y squared. And as xy approach to 0, okay, so the answer is simply going to be 1/8. 1/8. And let's see if that's correct. Okay, and here, find the limit. Find the limit of f as xy goes to 0, 0, or show that the limit does not exist. Consider converting the function to polar coordinates to make finding the limit easier. Okay, so we're just going to cheat. We're going to cheat for this problem again. I'm going to use Mathematica's limit function to make my life a little bit easier. Limit x to the power 3 minus x times y squared divided by x to the power 2 plus y to the power 2. So x and y, what is the limit as xy goes to 0, 0. And the answer is simply going to be 0. Okay. And let's see. That's it. Okay, so that covers problems 90 to 110. That covers problems 90 to 110 in part 1 of your chapter 12 homework. And once again, let me reiterate that this is going to be the last video until next week. So this is Thursday, October 15th, okay, 2020. So next week, I will do another video. I will do another video on the Chapter 12 homework. I will do another video on the Chapter 12 homework, probably part 2 of the Chapter 12 homework. But I'm afraid, guys, I cannot do any more videos for about a week because I'm really going to be pretty busy, for the next week. I have to do videos for the other 2 classes I'm teaching at Oakton, and I have to watch, videos on sexual harassment, Title IX training, all of that stuff. Racial issues in the classroom and racial issues on campus. I mean, there's a lot of stuff that I'm going to have to do, and I also have to review and submit the midterm class lists. So there's a lot of stuff I have to do for Oakton College. Okay, so I will continue to check my emails. I will answer emails, but I do need some time to get some important work done for Oakton College. Okay, I hope this video was helpful to you, and if it is helpful to you, if this video helped you, leave some feedback, leave a comment. And I guess that's about it. Okay? Take care. And I look forward to hearing from each and every one of you in the near future. Have a great week.